We're tackling the liver panel, one of the most misunderstood parts of the serum chemistry. Clinicians often see a high ALT and jump straight to liver disease, but that's only part of the story. By the end of this talk, you'll understand what each liver marker is actually measuring, why they don't all mean the same thing, and how to use them together to figure out what's happening in the liver, and whether the liver is actually the problem. Before we talk about the numbers, let's appreciate what the liver actually does, because the liver does a lot. It filters toxins, makes proteins like albumin and clotting factors, processes bilirubin, stores glucose as glycogen, and handles fat metabolism. When the liver is in trouble, one or more of these functions will start to fail, and that's what the chemistry panel is reflecting. Different markers reflect different functions, so a panel of liver values together tells a much richer story than any single number. Here's the most important framework for understanding liver markers. Divide them into three groups. Leakage enzymes tell you hepatocytes are being damaged and leaking their contents into the bloodstream. Induced enzymes, primarily ALP and GGT, tell you something is stimulating their production or that bile flow is being obstructed. And function tests tell you whether the liver can still do its job. Leakage enzymes can be wildly elevated even when the liver is functioning just fine. Function tests going abnormal means things are getting serious. This distinction will save you from over and underreacting to liver panels for the rest of your career. T is your most liver-specific marker in dogs and cats. It lives inside hepatocytes, and when those cells are stressed or dying, ALT spills into the bloodstream. Think of hepatocytes as bags of ALT. The more bags that break open, the higher the number goes. Magnitude matters. A mildly elevated ALT in a dog on phenobarbital or a dog that just had a stressful visit might be nothing to worry about. A markedly elevated ALT, 10 times normal or higher, is telling you there is significant hepatocellular death happening. One really important species note: the half-life of ALT in cats is much shorter than in dogs, about 6 hours versus 2.5 days. So a high ALT in a cat that's already trending down is actually good news. It means the insult may already be resolving. ALP is where things get complicated because it's not liver specific at all. It has multiple sources. In dogs, the most common reason for a mildly or moderately elevated ALP is glucocorticoids, either because the dog is on steroids or because it has Cushing's disease. There's actually a special corticosteroid-induced ALP isoform in dogs. Bone is another source. Growing puppies normally have high ALP, and bone tumors can elevate it. Cholestasis, obstruction of bile flow, is the classic hepatic cause. Now, in cats, the rules change. Cats have a very small ALP pool and a short half-life. So even a mildly elevated ALP in a cat is clinically significant and warrants a real workup. Don't dismiss it. Bilirubin is the yellow pigment that causes jaundice, that yellow tint you see in the skin, sclera, and mucous membranes of an icteric patient. When you see elevated bilirubin, your job is to figure out where the problem is in the pipeline. Is too much bilirubin being produced because red blood cells are being destroyed faster than the liver can handle? That's pre-hepatic, and it means hemolysis. Is the liver too damaged to process bilirubin normally? That's hepatic. Or is the plumbing downstream blocked, the gallbladder or bile duct, so bile can't get out? That's post-hepatic, and you'll often see a very high ALP alongside it. The three-category system, pre-hepatic, hepatic, post-hepatic, is your roadmap every time you see an icteric patient. We get to the function tests and whether these are the ones that tell you whether the liver is actually failing. Albumin is made only by the liver. When you see a low albumin in the context of liver disease, it means hepatocytes have lost enough function that they can't keep up with albumin synthesis. Because albumin has a long half-life, about 8 to 10 days, hypoalbuminemia is a marker of prolonged or severe disease. It doesn't drop overnight. BUN tells a similar story, but from a different angle. Urea is made in the liver during protein metabolism. A dog or cat with a portosystemic shunt or end-stage liver disease will often have a very low BUN. The liver simply can't complete the urea cycle. Low BUN in a patient with other liver abnormalities is a real flag. Bile acids are my favorite liver function test, and they're underused. Here's how they work. Bile acids are made in the liver, stored in the gallbladder, released into the intestine when the animal eats, reabsorbed from the gut, and carried back to the liver through the portal system to be recycled. The liver is incredibly efficient at extracting bile acids on each pass. If the liver is failing, or if there's a shunt bypassing the liver entirely, bile acids accumulate in systemic circulation. We measure a fasting sample, feed the animal, then measure again 2 hours later. Elevated postprandial bile acids are one of the most sensitive indicators of hepatic dysfunction. This is your go-to test when you suspect a portosystemic shunt in a young stunted animal with low BUN and intermittent neurological signs. Here's your systematic workflow for any liver panel. Go through it in order every time. First, are the leakage enzymes up? That tells you hepatocytes are being hurt. Second, are ALP and GGT elevated? Figure out why. Cholestasis, steroids, bone, or age. Third, is bilirubin up? And where on the pipeline is the block? Fourth, are the function tests failing? That tells you the disease severity. And fifth, step back and ask what single unifying process explains everything. Acute hepatic necrosis, for example, will give you a very high ALT, maybe mildly elevated ALP, normal or mildly elevated bilirubin early on, and function tests that are still holding. But if the animal isn't improving, those function tests will start to fall. Pattern recognition builds with experience, but the framework is always the same. Summary. Leakage enzymes, ALT and AST, tell you hepatocytes are being damaged. ALP is noisy and context dependent, especially in dogs. Bilirubin elevation needs to be classified into 3 possible origins. In the function tests, albumin, BUN, bile acids tell you whether the liver can actually do its job. Elevated liver enzymes alone do not mean the liver is failing. It's the function test that determines severity. That distinction matters enormously for prognosis and treatment decisions. Use the workflow every time, and the liver panel will stop being intimidating. Take a moment with this one. ALP is very high. ALT is normal. The dog has classical clinical signs. What's going on here, and why do these two enzymes disagree with each other? Cushing's presentation. The ALP is through the roof because glucocorticoids, whether from a pituitary tumor, adrenal tumor, or exogenous steroids, induce the production of a special ALP isoform in dogs. This does not mean hepatocytes are being killed, which is why the ALT is normal. The liver isn't being damaged, it's being stimulated to produce more ALP. This pattern, very high ALP, normal or mildly elevated ALT in a middle-aged to older dog with PUPD, pot belly, and skin changes is Cushing's until proven otherwise. The corticosteroid-induced ALP isoform is unique to dogs. Cats don't have it, which is another reason any ALP elevation in a cat is a bigger deal. Question 2. Young small breed dog, intermittent neurological signs that are worse after eating, and look at those bile acid results. Fasting is already elevated, postprandial through the roof. BUN is low. What's the diagnosis here, and why does eating make the neurological signs worse? This is a textbook congenital portosystemic shunt. Blood that should go through the liver, carrying nutrients and toxins from the gut, is instead bypassing the liver through an abnormal vessel and going directly into systemic circulation. After eating, the gut produces ammonia from protein digestion. Normally, the liver clears that ammonia. With a shunt, it goes straight to the brain, hence the postprandial neurological signs. Bile acids are one of the most sensitive tests for this condition, and this puppy's results are dramatically elevated. Low BUN completes the picture. The liver can't make urea because it's not receiving adequate portal blood flow. This dog needs imaging and likely surgical correction. Case. Here's a sick cat, icteric, not eating, and look at these values. There's a lot going on here. Let's break down what the low albumin is telling us, and let's specifically address whether that ALP elevation carries the same weight in a cat as it would a dog. Low albumin in this cat is telling you this isn't a new or mild problem. Albumin takes over a week to drop, so significant hypoalbuminemia means the liver has been failing for a while. That's a serious prognostic indicator. And yes, ALP in cats is completely different from dogs. Cats don't have the bone or corticosteroid isoforms to the same degree, and their ALP pool is small with a short half-life. So an ALP of 180 in a cat is much more alarming than the same number in a dog. In an anorectic cat, hepatic lipidosis is always at the top of the list. Cats mobilize fat aggressively when they don't eat, and that fat accumulates in hepatocytes and impairs function. This cat needs imaging and likely a liver sample.